Okay, students, now we're going to go through another example where we will need to apply the principle of moments to solve the question. So let us read the question. Find the value of F, assuming that the system is in equilibrium. So, can you still recall the 5 steps that we use to solve this kind of question? Alright, let us go through the 5 steps again. Step 1, identify the pivot. So, as mentioned, for this kind of questions, the pivots can be easily identified, and we know that this is the pivot. So once we have identified the pivot, we can move on to step 2, where we will need to identify the forces and the direction. As you can see here, the 3 forces that are involved in this question are the 10 Newton, F, and the 2 Newton. So the next thing that we need to do will be to identify the direction for the forces. Now let us take some time to identify the direction of the forces. Have you finished identifying the direction of the forces? Let's start from the 10 Newton force. Now from the 10 Newton force, what do you think is the direction of the 10 Newton force? Now, one thing you must take note is that the force is acting upwards. Hence, the direction of this moment is actually clockwise. Now, how about for F? What is the direction of the moment? Okay, I think most of you would have gotten it. It is anti-clockwise. Okay, and for the 2 Newton force, the direction would be clockwise. So we have 2 clockwise forces and 1 anti-clockwise force. So let us fill in the information right now. For the 10 Newton force, it will be clockwise, while for F it will be anti-clockwise. And lastly, for the 2 Newton, the direction of the force is clockwise. So once we have identified the forces and direction, step 3, we will need to identify the perpendicular distance. Identify the perpendicular distance. So let us look at the diagram again. So remember, what are the key concepts that we should apply when we measure the perpendicular distance? Now, firstly, you must form the right angle, and secondly, when you measure the distance, it must be from the pivot to the force. I repeat, the right angle from the pivot to the force. So for the 10 Newton, what is the direction of the force? What is the perpendicular distance? You realize that for the 10 Newton, the perpendicular distance will be 2 meter plus 4 meter, giving you 6 meter. How about the perpendicular distance for F? Same concept, it must form the right angle and the distance must be from the pivot to the force, and therefore the distance would be 2 meters. Lastly, how about the perpendicular distance for the 2 Newton? So same concept, form the right angle, distance from the pivot to the force. The distance is 6 meters. So with all this information, let us fill it in right now. So 10 Newton will be 6 meter. For F, it will be 2, and for the 2 Newton, it will be 6 meter. So once we are done with step 3, let us move on to step 4, where we will need to calculate the moment using the formula force times the perpendicular distance. So for the clockwise moments, we know that we have 2 clockwise moments, forces, the 10 Newton and the 2 Newton. And we know the perpendicular distance for the 10 Newton is 6 meter, for the 2 Newton is also 6 meter. So to calculate the total clockwise moment, we will use 10 Newton times 6 meter plus 2 Newton times 6 meter. This will give me a total of 72 Newton meter. How about for the anti-clockwise moment? Now, we only have F as the unknown anti-clockwise moment, and we know that the perpendicular distance for F is 2 meters. Using this information, we can then calculate the anti-clockwise moment to be equals to F times 2 meters, giving me 2F Newton meter. So, step 5, we will apply the principle of moments, where we know that in the principle of moments, the sum of the clockwise moment must be equals to the sum of the anti-clockwise moment. Hence, we can form an equation where 72 Newton meter must be equals to 2F Newton meter. So your F will be 72 divided by 2, giving you 36 Newton.